Okay, Miss Marsh here. We're going to be looking at section 9.3, area of trapezoids, rhombuses, and kites. So what you're looking at right now is something that you can download and print for yourself, which I expect for you to do. If you cannot print it, then you can just pretty much take the same notes on a piece of paper, although it's going to be a lot easier if you can print it. Okay, so first of all, we're going to go into some basics about what are trapezoids, rhombuses, and kites, and then we will talk about the area of each of these. All right, let's zoom in here. Okay, we're going to start with the trapezoid. Okay, so let's define what a trapezoid is. First of all of these shapes have four sides, which means they're types of quadrilaterals. A quadrilateral is just a polygon with four sides. So a trapezoid has four sides, and it has one pair of sides that are parallel to each other. So we talked about parallelograms, and they have two pairs of sides that are parallel. A trapezoid has one pair. So you can see this is the one pair. And so these are going to be what are your bases. Usually we call it base 1 and base 2. It doesn't matter which one you call 1 and 2. And so we sometimes we shorthand that with a little B and a 2. So this is going to be B1 and this is going to be B2. Okay, and then for the area formula, we're also going to need the height. The height is a distance between your bases, and again, it's perpendicular. So I'm going to draw a perpendicular line, segment. So perpendicular means it comes at a right angle, and whatever this distance is going to be your height, and it can be drawn anywhere. It can be on the inside of the parallel or the trapezoid, or it can be on the outside of the trapezoid. For example, I could draw it right here, and then I could just extend this side, and so this could be the height. Okay, so some characteristics. I'm going to type these. It's easier for me, but you can write them down. Okay, characteristics of a parallelogram or trapezoid. Sorry, I keep saying parallelogram. Okay, we have that has four sides, and there's not that many characteristics of a trapezoid. I already mentioned them, but you have exactly one pair of opposite sides that are parallel. You can't have two, because then you just get a parallelogram. Okay, and the height is perpendicular to the bases. We should say that the pair of parallel sides are called the bases. Okay. Alright, so that's what a trapezoid is. So let's talk about the area formula. So the area formula for a trapezoid is going to be 1/2 times the height times the sum of the bases. So B1 plus B2. Okay, so we have the height, and that height is perpendicular to the bases. Excuse me. The bases, you have B1 here and B2, and they are essentially right here, and make that a little thicker, right here. Okay, they are the parallel sides. Okay, so you take their lengths and you add them together, and notice the parentheses, and then we cut them in half. Okay, so let's do a couple of problems. So we have some examples. So first we need to identify what are your bases. So our bases in this case are 16 and 9 because they are the parallel sides. Okay, it doesn't matter which one's B1 and B2. And then our height is going to be right here. That is your 10 feet. Okay, so let's plug it in. So the area is equal to 1/2 times 10 times 16 plus 9. So we want to follow the order of operations. We got to add first. 16 plus 9 is 25. And then sort of just like we do the area of a triangle formula, I like to see if I can cut anything in half. I can cut the 10 in half, so that's 5. And then I'm just multiplying 5 times 25, and that's 125 square feet. There's our answer. Now I included a second problem because it's a little bit more difficult. Looking at our bases, I see this one right here is 11, but then what's this one? Well, it's not that difficult. If we just look, we can see this is 2, and then since this is a rectangle, we can see the right angles. This is also 11. So that makes the whole base 13. Okay, so I have my B1 and my B2 now. I need H though. You'll notice they gave me an extra piece of information here. They gave us the 6. That's not the height because it's not perpendicular. Whatever this is the height. And so to find that height, which I'm going to call H, we're going to have to do the Pythagorean theorem. Okay, remember with the Pythagorean theorem, that's a squared plus b squared equals c squared in a right triangle only, which is this guy right here. So we have this is 6, this is 2, and this is H. So we're going to do H squared plus 2 squared equals 6 squared, which is H squared plus 4 equals 36. Subtract 4. We get H equals the square root of 32. I'm going to leave that there for now, and then let's just plug everything in the formula. So I have 1/2 times the height, which is the square root of 32, right? That's what we were looking for, the height, times the sum of the bases, so 11 plus 13, which is 24. So we have half of 24. Half of 24 is 12. Okay, and then you may remember from a couple of chapters ago we learned how to simplify a square root. This is 16 times 2. The square root of 16 is 4. So the square root of 32 is actually 4 square root of 2. And then that 4 would multiply times the 12. And so we get a final answer of 48 rad 2. Now in Math Excel you're going to have to look to see if they want a radical answer or a decimal answer. If they want a decimal answer, we would have to take 48 and multiply it times the square root of 2. You get a decimal. If they don't want a decimal, then you're just going to leave it like this. The decimal answer turns out to be about 67.9 square feet. Alright, next shape, the rhombus. So the rhombus is a special type of parallelogram, actually, because it does fit the definition where you have two pairs of parallel sides. This would be parallel to that, and this would be parallel to that. But it's special because you could see you have 4 congruent sides. A parallelogram does not necessarily. Now this could be a square if all of these angles were right angles, but it's not necessarily a square. So the idea here is we're getting a formula that just works for rhombuses, although we could use a square formula if it was a square, and we could use a parallelogram formula because it is a parallelogram. So the things that we need to know about a rhombus Let's type these into the, or you can write them into the characteristics box. We've got that it is a special type of parallelogram with 4 congruent sides. It also has these things called diagonals that we're going to need to use. The diagonals, let's highlight the diagonals here for you. The diagonals are, well, let me use a different color so you can see it. There we go. This is a diagonal, and this is a diagonal. The diagonals go from one vertex to the other, but they're not already connected with a side. Okay, so you can see there that the diagonals are perpendicular, so they come together at a right angle, and they also see that C is a midpoint. C right here is the midpoint of this segment, and it's this mid segment. So what we say is the diagonals are perpendicular and they bisect each other, which means they cut each other in half. Okay, so those are some characteristics of a rhombus. Let's talk about the formula for the area. Well, the formula I'm going to show you comes from the area of these triangles. Okay, when you draw the diagonals, you get 4 triangles here. You see the triangles? There's one, and then there's 3 more that are the exact same size. Well, if you find the area of one, you can multiply it times all, like 4 of them. So the formula is going to use the diagonals. We're going to call this diagonal, it doesn't matter which one, I'm just pick whichever one, D1 for diagonal 1. And this diagonal is D2 for diagonal 2. Okay, so our formula, let's see if I can keep that all there. You're going to do area equals 1/2 times diagonal 1 times diagonal 2. Alright, so basically we have the diagonal, the whole diagonal is diagonal 1, and the other diagonal, the whole thing is diagonal 2. Okay, so let's do a couple examples. So find the area of each rhombus. Okay, well, in a rhombus you have to remember a few things. You have to know that these are perpendicular. You have to know that this is congruent to that, and that's congruent to that. That comes from the idea that the diagonals bisect each other. So they tell us that this little piece right here is 25. Because the diagonals bisect each other, that tells us this is also 25. And same thing over here. If this is 22, this is 22. So to get our diagonals, our D1 and our D2, which we need for our formula, you have to see the whole picture. So diagonal 1 could be this whole thing. And so that would be 22 plus 22, or 44. Diagonal 2 is going to be this whole thing, which is 25 plus 25, or 50. So the formula is 1/2 times 44, diagonal 1, times diagonal 2. Okay, once again with the half, we could just cut one of these things in half. So I'm going to cut the 44 in half, and that's 22. And then 22 times 50, I think that's 1100. Yeah, 1,100 square feet. Okay, example 2. Again, we're going to have to recognize all those things that we said in the beginning. The diagonals are perpendicular and they bisect each other. So already I know that this is 4. Now this one doesn't have either of them. And then they gave me a side, 6. So this side right here, 6, is absolutely useless to me. It's not used in the formula. Well, I shouldn't say it's absolutely useless. What we're going to need to do is, just like in this example over here, we're going to have to do the Pythagorean theorem to find this. So we're going to take this right triangle. This is 6. This is 4. This is unknown, so I'll call it x. So then Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. So that's x squared plus 16 equals 36. Subtract 16. X squared is equal to 20. Take a square root of 20. It's not a nice number, so I'll just leave it like this for right now. But we can simplify this. This is 4 times 5, so that's 2 rad 5. When you take the square root of 4, you get 2. Okay, so now I know what this is. It's 2 square root of 5. And I also know what this is. It's 2 square root of 5. So now, let's get my diagonals. Diagonal 1, we'll call the first one is 4 plus 4. So that's going to be 8. Diagonal 2 is going to be 2 rad 5 plus 2 rad 5. And so you can add radicals like this. Think of them like 2x and 2x is 4x. So this is going to be 4 rad 5. So plugging it into our formula, we're going to have area equals, 1/2 times 8 times 4 rad 5. Half of 8 is 4. 4 times 4 is 16. So 16 rad 5 meters squared. All right, last one, the kite. So the kite has a lot of similarities to a rhombus. You'll notice the diagonals are perpendicular. The definition of a kite is it has 2 pairs of congruent sides that are next to each other but not opposite of each other. So these 2 sides are congruent and these 2 sides are congruent. So it makes it look like the toy kite, right? Alright, so let's type in the characteristics. So we have 4 sides, 2, cannot type pairs today, pairs of consecutive just means next to, congruent sides, but not opposite from each other. And you have diagonals that are perpendicular. Okay, but they don't both bisect each other. You do get one of them that gets bisected, but not both. Okay, so the formula is actually really nice because it's the same exact formula that we just used with the rhombus. You have a diagonal 1 and a diagonal 2. Okay, so the diagonal 1 is this whole length. Diagonal 2 is this whole length. You just do the same exact formula, which was area equals 1/2 times diagonal 1 times diagonal 2. Okay, so then diagonal 1 is the whole thing, diagonal 2, whole thing. Okay, so we're going to find the diagonal 1 and the diagonal 2. Diagonal 1 here, remember, it doesn't matter which one you call diagonal 1, diagonal 2. Let's cut this one. So diagonal 1 would be the sum of 2 plus 6.5, which is going to be 8.5. Diagonal 2 is our other one here. See, this one's the one that's got the midpoint. It's 4 and 4 because these are congruent. So it's 8. So diagonal 2 is 8. So same formula, area equals 1/2 8.5 times 8. I'm going to cut the 8 in half and then multiply 8.5 times 4, and that gives you 34 square feet. Okay, that's the end of this video. Make sure to go on to Math Excel and do the homework for this section.